longitudes, but the big story follows it in rotation to the left. The brightness there and extended arches of the umbral magnetic fields tell us it's a massive sunspot, and it is. It crested into full view over the last day, and even with suboptimal visibility near the limb, we can tell it's a beast of a sunspot group. Even titans like this don't flare too terribly this early in the cycle, but it does tell us that the sun has the gears to kick it in. Going to be some rough years ahead. Up next is dueling forecast for the rest of the month in the U.S. This is NOAA's, showing they expect a hot penultimate month of the year, but the Weather Channel has a considerably different forecast. Heat confined mostly to the west coast, while we get a more usual La Nina mix of a warm southeast and cold Midwest. The following weeks will tell. Quick look next at the top quake of the last day, offshore and only noteworthy as again the largest magnitude of November 2. Folks, this one is screaming magnetic changes of Earth. A few months ago, NASA finally confirmed that whale beachings are related to solar storms and changes in Earth's magnetic field. No solar storms this week, and the largest ever pilot whale stranding in Sri Lanka just took place, near where the magnetic poles are set to collide on their current shift. Silver lining is they saved almost all of them. Let's go to the papers and start with the response to the attempts to debunk the Maunder minimum. They were admirable, but mistaken. The methods used are shown to be flawed, and the last grand minimum stands. Folks, up next, we're going to see a simple conclusion carrying a big stick if you are familiar with the plasma cosmology version of the universe. The more they look and stack images and improve technology, the more dust and plasma they find in electromagnetic systems and patterns, and yet nobody ever goes back to add those into those models that demanded dark matter decades ago. While we're adjacent to that finish line here, they do identify that dust, when not self-interacting or gravitating in models, is missing a ton of its potential action at scale. When they are modeled properly, they are able to cause collapse of scattered material into molecular clouds. Remember, dust aligns and follows the magnetic fields. This next paper was relevant for a few deep-level interests of a plasma physics nerd, but one of the foundational principles is not well known by most, yet it's vital. The Earth maintains an electrical equilibrium with its geospace environment. What energy comes in goes out the magnetotail-facing side of the planet. Those with us earlier this year remember the summer heat brought lightning advancement into superbolt territory, with Earth discharging. We describe this as being the excess energy in with the weakening magnetic field of Earth, causing greater discharging out. And that's what the highlighted portion is talking about, the foundation. We have recently and for a while gone over the risk of superflare or micronova shockwave compression of the sun-facing L-shell fields to the point of discharge downward. And we've examined the theory, science, and evidence of past events on Earth, but we've never discussed the discharge that follows. Remember, what goes in must come out. Folks, whether there is a sun-facing arc discharge or the energy successfully integrates into the field, ionosphere, atmosphere, and oceans, that energy is going to have to come back out as well. Speaking of which, energy moving through the crust continues to be shown to be a major way to predict earthquakes. There are thermoelectric, pyroelectric, piezoelectric, and capacitance-based translocations of things like olivine and water. The Greeks are onto it as much as anyone else. NASA jumped on the wagon a year after China and Italy, and now with 3 major textbooks on this subject, it is maturing nicely. This is how we've done it since 2016 over at QuakeWatch.net, the Earthquake Prediction Center. And last but not least, one of the top climate journals, if not the top climate journal, discussing the merit and success or lack thereof when it comes to decadal climate predictions. About the only good news for climatologists is that some improvements in accuracy over each of their models can be made with an ensemble, just taking all the models and averaging their results. However, the things we've discussed all year, the CO2 bias, error propagation, all stemming from cloud uncertainty and grant funding. When it comes to actually predicting the future, the climate models have a lot of work to do to be useful to stakeholders or anyone other than the people that have taken billions in that grant funding for decades, to wind up at a lot of work to do to be useful.